Today 8's video of system of linear equations and linear inequalities. You can see that today we're doing the same thing we did in day 7, linear inequalities, except we're doing systems of linear inequalities, which means that you're going to continue to graph these linear inequalities, which end up being lines with shading on them, and you're going to just do two of them on the same graph. And visually, we're looking for where the two shaded regions overlap. Now in this video, I'm going to choose different colors to help color code and guide what I'm doing today. So the first equation I'm going to do in blue, second equation I will do in red, so that way when you see my drawing on the board here, you'll know which line is which. Now, if I look at the first equation, y is greater than, it should be inequality, y is greater than negative x minus 2. First, identify what the slope is. What is n? And if it's not in slope-intercept form, that is y equals mx plus b, you should always solve for y first. So I got the y by itself, and I have this inequality sign there. So the slope is still applicable. It's negative 1. That means I go 1 down and 1 over for every point on the x-axis. And I know that my b value is negative 2, so my y-intercept would be 0, negative 2. So if I go over here, I'll label my graph and just make my scale appropriately so you know which box is which. 0, negative 2 will be the spot of the blue line. Now I have to decide before I start making these points whether the line is going to be solid or dotted. Now because there's no equality underneath the sign, this will be a dotted line. Okay, so when I start to plot these points, the slope is negative 1, so 1 over 1 down, so 1 over 1 down, 1 over 1 down, 1 over 1 down, and so on. And I'll use my ruler here. Let me get my math tool out here. So I'm going to take my ruler, connect the dots there as best as I can. This one will be a dotted line, so that means that as I draw this, I want to make sure that I don't color in completely. I'm going to make, just like when you cut with scissors, oops, shifted a little bit there. Just like when you color or cut with scissors, you want to make a dotted line like that. And that just indicates whether the line is part of the solution set, part of my shading. Okay. So now I've graphed the line, made it dotted because it had no equal sign. Now I have to do a test point. So I'm going to do my test point for blue and purple. And so I have to write this test point down. We're going to have a quiz tomorrow on Friday. I'm going to make an announcement on Schoology, but if you're watching the video, you'll know we have a quiz. We will review before the quiz. But you have to show your test point before you start to shade. Tell me what you tested to determine whether you shaded. So I'm going to test 0, 0, and that's above my dotted blue line. And I'm going to plug it into the original inequality right over here. 0 is greater than 0 minus 2. Is 0 greater than negative 2? True. That is true. That means I will shade where that dotted point was. And 0, 0 was right here. I'll mark that test point, 0, 0. And it was true, so I will shade where that test point was. And that's going to be above here. Okay, now it's time to do the other inequality. So down here, what's my slope? Negative 5. What's my y-intercept? 0, 2. So go ahead and plot that point, 0, 2. Now, solid or dotted? It's going to be dotted. Okay, so that means that I will go down 5 over 1, down 5 over 1, up 5, left 1, and so on. I'll use my ruler again. And I will connect those dots. Okay, it takes a little while for me to do this, so just give me a moment, please. So not quite there. That looks pretty good. About as good as I'm going to get. So I'm going to make this another dotted line. And it's dotted because there's no equality underneath that inequality sign. Okay, so there's my second line. Now I have to pick a test point for this line, and I'm going to do that in green. And again, I'm going to test something that's really easy to test, this 0, 0 line. I can see clearly it's on the left side of the red line. So I'm going to test 0, 0. And again, to get full credit, you have to tell me what the test point was. All right, so I plug that into my original inequality. 0 is less than negative 5 times 0 plus 2. 0 is less than 2. Is that true? It is. So that point worked. That means I'm going to shade to the left side of the red line. Here's my red line. Follow that down here. Try not to go over it. And go over. You see now I've shaded two regions, a blue and a reddish pink region. And my solution set is where they overlap. So I'm going to color that in darker here. This region where I have both blue and red is going to be the solution to this system of linear inequalities. So on your paper, just make that part darker. Color that in. Okay, that means any point that's in this region satisfies both inequalities at the same time. Let's do another one. And this time I'm going to use, again, blue for the top line and then red for the bottom line. Oops. Let's do the bottom line first. What's the slope? -2. Y-intercept? 0, -3. Solid or dotted line? Dotted. No equality underneath there. So then the slope is -2, so I go 1/2 down, 1/2 down, 1/2 down. If I go left, I'm going to go up 2. See how that works. Grab my ruler. Connect those dots, but make sure it's a dotted line and not a solid one. A little bit more. Okay, there you go. Arrows in the end. All right, now we need to test the point. I'm going to use green again to test my red line. So the test point, pick an easy one. 0, 0 is on the right side of the line, so I'll test 0, 0. Plugged into the original inequality. 0 is less than -2 times 0 minus 3. Okay, is that true? Is 0 less than 0 minus 3? Is 0 less than -3? No, it wasn't. So do you see where that green dot was? Since that was not a solution, I'll shade on the other side of it, which will be right over here. 0, 0 did not work, so I'm going to shade on the other side. Good. Let's do the blue line now. Slope, 1/2, it's a fraction. 0, 2. Up here, slope's 1/2, 1/2, solid or dashed line? Well, you can see there's equality this time, so it should be a solid line. All right, grab your ruler or other straight edge. If you're doing this without a ruler at home, just do your best, try to make it as straight as possible. You can use the edge of a sheet of paper or an edge of a book to help you out. But notice how I connect this one to make a solid line, and that's because I had the equality. This one is solid. We'll test the point. Okay, the point was, do 0, 0 again. Now you sometimes can't do 0, 0. You can't do 0, 0 if it's passing through the line. If the line itself went through that point, I'd recommend choosing a different one. So if I plug that in here, I get 0 is less than 1/2, and by plugging them in, I mean substitute into these two right here. 0 plus 2. 0 less than 0 plus 2. I would say it is true. So this time it did work, so I will shade the side that had 0, 0 in it, which is the right side of the blue line, which is below it. You see we have quite a large overlap region here. My ruler is kind of in the way. Let me put that away. So there you have it. You see where the red and the blue overlap. That's going to be my final solution. So I'm going to color that in dark. Maybe outline it first. Then just color that in darker than the other stuff. That's my solution. Any point in that area will satisfy both inequalities. Now we have a very unique inequality on this one. And I'm going to use different colors just to change it up. I'm going to use orange for the top one. And let's use maybe purple for the bottom one. Okay, here's a very unique inequality. X is less than or equal to 3. If x is less than or equal to 3, there is no slope or y-intercept. It's not in slope-intercept form. In fact, I just have the x. If I made an x and y table, what would x always have to be? -3, -3, -3. And I could have -2, 0, 2. I made these points up. So I chose. Okay. I just chose -2, 0, and 2. I just know that x has to be -3. So if I go here, here's my y, here's my x. I know I've been bad about labeling these, but by now hopefully you understand how to label that. Oops. So here's x is -3 right there. It's going to be a vertical line. So if I plot those points in orange, -3, -2, -3, 0, -3, +2. It's going to be a vertical line, up and down. So, solid or dotted? This is going to be solid because it has the equality. So take my ruler now. This will be an easy one to draw straight because I can just follow the grid line. Okay, not quite there yet. One more degree this way. There we go. Of course I missed. Let's try it again. There we go. Right on there. Pick a test point. Now, test points for these when you don't have a y can be a little confusing because what do you put in for y? If I test with 0, 0, that gives me an x and a y value. What do I do with this y? Well, there's no y to plug into. So I just plug it into the original one, and I just plug in 0 for x, and there's nowhere to put that other 0, but that's okay. Is 0 less than or equal to -3? Nope, it's not. So it's on the right side here. That did not work, so I shade the other side. Use an orange here, so I shaded on the left side because that point did not work. Let's try another one. I guess we're done with that one. Let's do the next one down here. So, slope, I should use purple. Slope is 5/3, 5 over 3. Intercept is 0, 2. 0, 2. Then I go up 5 over 3. 1, 2, 3, 4, 5 over 3. Then 1, 2, 3, down 5. Solid or dotted line? No equality. It would be dotted. So grab your ruler. Connect these dots here. Carefully keep track of which dots go on the line. So that one's dotted, so I actually should have made that dotted. I'm just going to use a small eraser, and I'm just going to erase some. Now it's dotted. So if you make the same mistake that Mr. Levis just did, just erase the dotted line with an eraser, and you make your solid line into a dotted line. Okay, graph that. Now test the point. I'm going to test 0, 0. I'll do that a different color. All right, test. I'm going to test with the original inequality. So if 0 is less than 5/3 times 0 plus 2, it's 0 less than 0 plus 2. Is 0 less than 2? It is. So that point worked. My 0, 0 worked. So that means I shade below that line. It's going to be down here. I should make that purple. Oops. Sorry about that. The wrong button there. You see where the overlap of the orange and the purple is. And that's your solution, right down here. The longest parts of these problems is actually drawing the graph. Okay, so I think you get the picture here. I'm not going to do this entire problem. I'm just going to show you how to get this into y equals mx plus b form. If I have 3x plus 2y is greater than or equal to -2, I have to arrange things differently. I first have to subtract the 3x to make it go over to the other side. And then I'm left with 2y is greater than or equal to -3x minus 2. Then I have to divide by this positive 2. Now you have to be careful. If that was dividing by a -2, what would happen to that inequality sign? It would flip. Okay. So now I have my line or my inequality in slope-intercept form, and I can graph it when I'm needed to. Down here, I'll do one more example. 2y is less than 2. 2y is less than or equal to 2 minus x. I'll divide by 2. Y is less than or equal to negative x over 2 plus 1. Y is less than or equal to negative 1/2 x plus 1. I was doing some rearranging with the x's and the 2's there. Don't be afraid of that. That's all the time I have for this video. I hope you have a good weekend, and we have a quiz tomorrow, so don't forget to study. If you have questions, please let me know. Have a good day.